Friends, good morning. In this session, we are going to discuss the binomial theorem, JEM and problems. Okay, in the last class, we have done some problems. We are continuing some other problems. Okay, let's just start now. The problem: the coefficient of x to the power of 7 in the expansion of 1 minus x square plus x cube whole to the power of 6. We have to find the coefficient of x to the power of 7 in this given expansion. Okay, see the solution. Okay, see the solution. What is the given expression? That is 1 minus x square plus x cube whole power 6. Now this can be simplifying here. This is here 1 minus x. In the last two terms were common x square. X square is common, minus x square is common, 1 minus x. Okay, whole power 6. In these two here 1 minus x is common. 1 minus x is common. We get here 1 minus x square whole to the power of 6. Okay, that is nothing but 1 minus x whole power 6 into 1 minus x square whole power 6. Now we are writing this is in the sigma notation. So here r is equal 0 to 6. 6cr here minus 1 power r into x to the power of r. So this is the expansion. So this expansion, the second term here we are taken sigma s is equal 0 to 6. So here 6c s here minus 1 power s into x square whole to the power of s, that is x square whole power 2s. Okay, this is the expansion. Now this can be written as here sigma r is equal to 0 to 6 and sigma r is equal s is equal to 0 to 6. Here 6cr into 6cs minus 1 power r plus s, and also here x to the power of r plus 2s. Here x power r, here x power 2s. The power is x power r plus 2s. Okay, so these are the terms in the expansion of given expression. Okay, now we are finding the coefficient of the coefficient of x to the power of 7. We are taken r plus 2s is equal to 7. R plus s is equal to s7. So we are taken s and r. The total sum is r plus 2s is 7. If you take s is equal to 1, we are 2 plus remaining is 5. So if r is s is equal to 2, that is 2 into 2 4, that is 4, remaining is 3, that is 3. Next s is equal to 3, that is 2 into 3 6, we are taken r is equal to 1. So these are the chances. The total sum is r plus 2s is equal to 7. Now we are writing the coefficient of x power 7, coefficient of x to the power of 7 in this expansion is equal to, we are taken, suppose what is here, r is equal to s, that is the coefficient here 6c, what is r is 5 and 6c, s is 1, here minus 1 power. So here r plus s, that is 5 plus 1. Next one is we are taken s is equal to and r is equal to 3. Now that can be, so 6c here r is equal to 3 and 6c s is equal to 2. Here minus 1 power 2 plus 3. That is next one is 6c. What is yes, r is equal to 1, 6c1 and 6c3 minus 1 power here 3 plus 1. Now we are simplifying this one. Here 6c5, that is nothing but 6c1. This is 6 into here also 6c1, that is 6. Here minus 1 power 6, that is we are getting positive here. Next one is here 6c3, that is nothing but 6c2, that is nothing but 6c3, that is nothing but 6 into 5 into 4 by 3 into 2, that is 5 4 20. This value is 20 into 6c2, that is 6 into 5 by 2, 2 3s are 3 5s are 15. So here 15. Next minus 1 power 2 plus 3, that is minus 1. We are getting here minus. Okay, this is a minus. The last one is 6c1 is 6 and 6c3 is 20. Here minus 1 power 4, that is plus. Okay, that is here 36 minus, this is 300 plus here 120. Okay, so that is nothing but here 156 minus 300, that is minus 144. Okay, this is the coefficient of x to the power of 7 in the given expansion. Okay, so see that once again. I can't recall it. So this is the given expression. Here x square is common, then we are getting 1 minus x. Here 1 minus x is common, then we are getting 1 minus x square. Now splitting these two, 1 minus x whole power 6, 1 minus x square whole power 6. Now write the binomial expansions for both these two. Now we are writing here x power r plus 2s. So we are finding the x power 7 coefficient. This r plus 2s is 7. Now we are writing the chances of r and s, but the sum is 7. We are taken the chances. So now we are writing the coefficient of x power 7 in this expansion. We are writing r and s values. We are writing the coefficients of x power 7. The sum is we are getting minus 144. Okay. The problem. The remainder left out when 8 power 2n minus 62 whole power 2n plus 1 is divided by 9. We have to find the remainder. So when it is divisible by 9. Okay, this expression is divisible by 9. We have to find the remainder. Okay, see the solution. So what is the given expression? 8 power 2n minus 62 whole power 2n plus 1. Now this can be written as 8 square whole power n minus 62 whole power 2n plus 1. This 8 square 64. 8 square 64 power n minus 62 whole power 2n plus 1. So that is this can be written as 1 plus 63 whole power n. This can be written as 63 minus 1 whole power 2n plus 1. That is now we are writing the expansion here. NC0 plus NC1, where NC1 into 63, NC2 63 square and so on, NC n 63 to the power of n minus here 60 2n plus 1. Now we are writing 2n plus 1 C0 into 63 to the power of 2n plus 1 minus 2n plus 1 C1 63 to the power of 2n plus so on. In the last term 2n plus 1 C 2n plus 1 into 1 to the power of 0, that is nothing but 1. Okay, now this is the expansion. Okay, now we are writing here NC0 is 1, here n plus 1 2n plus 1 c 2n plus 1 is also 1. Here minus of minus plus. Here 1, this is also 1. This 1 plus 1 we are taken 2. In the remaining terms, all terms there is 63 factor. So now we are common the 63. We are getting nc1 plus nc2 63 and so on ncn 63 to the power of n minus 1 minus okay, here minus. So these are the terms here 2n plus 1 c naught 63 to the power of 2n plus 1 c1 63 to the power of 2n minus 1 and so on. In the before that 2n plus 1 c 2n 63 to the power of 2n. Okay, so this is the sum of all binomial coefficients product on integers. Okay, this is some integer. Now this can be written as 2 plus 63 into some integer. Here k is some integer, where k is some integer. Okay, now this can be written as so here this can be written as 9 into 7k. Okay, where k is some integer. Okay, so this also can be written as 9 into 7k. So 7k is some integer. Now we are taken this is some integer capital K, where k is some integer. Now this given expression can be written as so 9 into some integer plus 2. Therefore the remainder is equal to 2. Here this is the remainder when it is divisible by 9. When it is this given expression is divisible by 9, is the remainder is 2. This is the remainder. Okay, see the problem. In the binomial expansion of a minus b whole power n, where n is greater than or equal to 5, the sum of the fifth and sixth terms is 0. Then a by b value. Now I have to find the a by b value. Okay, see the given expression. See the solution. So given expression is a minus b whole power n. In that fifth term and sixth term sum is 0. So and here given fifth term t5 and t6 sum is 0. In the binomial expansion, the sum of the fifth and sixth terms is 0. That is the given data. Now that is t5 plus t6 is 0. Now we are writing the fifth term, that is nc4. We are taken r is 4. What is general term? tr plus 1 is ncr a power n minus r b power r. So here we are taken r is 4 into first term a to the power of n minus 4 and what is here minus b to the power of 4. Okay, next sixth term, that is nc5 a to the power of n minus 5 into minus b to the power of 5 is equal to 0. That is here nc4 a to the power of n minus 4 b to the power of 4. Okay, here if power is even, then we are getting positive. Here minus b to the power of 5, here odd, we are getting here minus nc5 a to the power of n minus 5 b to the power of 5 is equal to 0. Now we are writing this is nc4, that is n factorial by n minus 4 factorial into 4 factorial. Here a to the power of n minus 4 b to the power of 4. The remaining here n factorial by n minus 5 factorial into 5 factorial into a to the power of n minus 5 into b to the power of 5 is equal to 0. Now we are common from these two, here n factorial by this, here n minus 4 factorial is common, here n minus 5 factorial, here n minus 4 into n minus 5 factorial. So here n minus 5 factorial is common, here n minus 5 factorial is common, here 4 factorial, here 5 factorial. So now we are taken 4 factorial is common, then here remaining terms are a power n minus 4 into b power 4 minus here n factorial. So here n minus 4 factorial can be written as n minus 4 into n minus 5 factorial. So here n minus 5 factorial in the remaining denominator n minus 4. Here 4 factorial is common. Here n factorial is common. Here a power n minus 5 into b power 5 by this is here n minus 5 factorial is common. Here we are getting only 5. N minus 5 factorial is common. Here 4 factorial is common. Here n minus 5 factorial is common. Here 5 factorial can be written as 5 factorial into 5 into 4 factorial. Here 4 factorial is common. Okay, this is equal to 0. Now this value is not equal to 0. The remaining term is 0. That is a to the power of n minus 4 by n minus 4 into b to the power of 4 minus a power n minus 5 b power 5 by 5. This is 0. Okay, now we are writing this is 0. Now we are taken this is 0. So from that we are writing this value is a to the power of n minus 4 by n minus 4 into b to the power of 4. This is moving to this side, a power n minus 5, a power n minus 5 into b to the power of 5 by 5. Okay, now this b power 4, here 5 minus 4, this is 1. Okay, now here a to the power of n minus 4, this term is moving to this side, minus n plus 5. Here b power is cancelled. Now this n minus 4 is moving to this side, n minus 4 by 5. Okay, now here b is moving to this side, b power 4, here b power 5. So 5 minus 4, that is 1. Here we are getting, here minus n plus n is cancelled. A power 5 minus 4, that is 1. A by b is equal to n minus 4 by 5. We are getting a by b is equal to n minus 5 by n minus 4 by 5. This is the value of a by b. So this is the value of a by b. So given expression is a minus b whole power n. In that the sum of fifth term and sixth term is 0. Now we are writing the fifth term and sixth term. Now we are common n factorial by n minus 4 factorial into 4 factorial. So the remaining two terms is here, that is 0. So this is not equal to 0. The remaining factor is 0. Now from that we are simplifying. We are getting a by b is equal to n minus 4 by 5. Okay. See the problem. The sum of the series 20C0 minus 20C1 plus 20C2 minus 20C3 and so on 20C10. Now we have to sum of the series. See the solution. So consider 1 plus x whole power 20. Now we are consider this is the expansion of 1. What is here? 1 plus x whole power 20. In this expansion, what is the expansion? 20 C0 plus 20 C1x plus 20 C2 x square and so on 20 C20 x power 20. This is the expansion of 1 plus x whole power 20. In that expansion, now I have to substitute x is equal to minus 1. Substitute x is equal to minus 1. Then we are getting here minus 1, 1 and minus 1 will be cancelled. Here in this, this is the 1 plus x, the term is 0. In the remaining, put x is equal to 0, 20, c naught here minus 20, c1 here plus 20 C2 minus 20 C3 and so on minus 20 C9 plus 20 C10 and so on 20 C20. So this is the expansion. In that expansion put x is equal to minus 1, we are getting this one. So this is the series here 20 up to this we are writing here. So in this these last these terms we are writing 20 C10, that is nothing but 20 C10. Here writing 20 C20, that is 20 C naught. Okay. Now these terms and these terms are nothing but the same. Now we are writing here 20 C2 times of 20 C naught minus 20 C1 plus 20 C2 minus 20 C3 and so on minus 20 C9. These terms is nothing but now put x is equal to minus 1 in this expansion, we are getting this one. Now using this formula, now we are writing this is 20 C0, 20 C1 plus 20 C2 and so on minus 20 C9. Now this can be written as here 20 C10, that is 20 C10. So now we are writing so from last to this one, this is 20 C20 minus 20 C19 plus 20 C18 minus and so on. What is the term is 20 C10, that is 20 C10. Okay, now we are writing this one is nothing but 20 C0 minus 20 C1, 20 C2 and so on minus 20 C9. Here this can be written as 20 C20, that is 20 minus 20, that is C0 minus 20 C, that is 20 minus 19, that is 1, that is 1 plus 20 C2 and so on. Here the last term 20 C10, that is 20 C10. So before that 20 C9. Okay, 20 C9 minus 20 C9. Okay, now these terms and these terms are the same. Okay, now this is the 2 times of 20 C0 minus 20 C1 plus 20 C2 and so on minus 20 C9 plus here 20 C10. Okay, these terms are the same. These terms are the same. Okay, remaining we are getting the 20 C20. Now we are adding on both sides 20 C10. We are getting 20 C10. Now we are getting from this 2 times of 20 C0 minus 20 C1 plus 20 C2 and so on plus here 20 C20, 2 times of 20 to 2 is common, 20 C10. So now we have to write the required series 20 C0 minus 20 C1, 20 C2 and so on 20 C10 is equal to, this 2 is going to this side, 1 by 2 into 20 C10, 20 C10. Okay, this is the sum of the series. This is the sum of the series. So 20 C0 minus 20 C1 plus 20 C2 and so on. 20 C10 is equal to 1 by 2 into 20 C10. Okay.